In this work, we present the proposed pyramid dilated attention network for action detection. Action detection, often known as temporal action localization, is an important computer vision problem, whose target task is to find precise temporal boundaries of actions occurring in an untrimmed video. In daily life, human actions are continuous and can be very dense. Every minute is filled with potential actions to be detected and labeled. There are two main challenges while handling densely annotated videos. Firstly, humans are great at performing concurrent actions. They can drink while reading books, or take a phone call while putting something on the shelf. Secondly, the duration of actions can have a large variance. This holds true for actions that are closely related and for instances of the same action class. Previous temporal modeling methods, standard temporal convolution network, allocates the same importance to local frames in the kernel. This property prevents the temporal kernels from selecting the key information in untrimmed videos. To tackle this, we introduce PDAN that can provide relative attention weights that benefits modeling of complex temporal relations. The whole pipeline consists of three main components: a video encoder, a temporal filter, and a classifier. The proposed PDAN is a temporal filter that processes on top of the video segment representation encoded by I3D. Our primary novelty lies in the attention mechanism of the dilated attention layer, which is a basic component of PDAN. Different from the traditional method, whose receptive field covers the full video, the proposed method's receptive field at each time covers only the neighboring frames in the kernel. Therefore, the learned attention map represents the relation between the center frame and its neighboring frames in the kernel. While changing the receptive field, the model can handle action patterns at different lengths. This design enables the attention mechanism at each layer to focus on actions of different temporal lengths. As a result, the proposed method can provide better context information and filtering irrelevant information from the distant actions. PDAN is based on a pyramid of blocks. Each block is a cascade of a dilated attention layer with ReLU activation, bottleneck convolution, and a residue link. Dilated attention layers have the same kernel size but different dilation rates. The pyramid increases exponentially the size of the receptive field of the model. This structure allows the network to model short and long action patterns. To learn the parameters, we optimize the multi-label binary cross-entropy loss. The experiments shows that PDAN can precisely detect both short and long actions in densely annotated videos compared with I3D baseline and TJM with super event. The proposed method also has the following features. Firstly, the dilated attention layer needs few extra computations compared to standard temporal convolution kernel. Secondly, the proposed method is more effective than the one-dimensional non-local block, while using a sparse attention representation. Thirdly, dilated attention layer can be embedded into other structures, for example, time section. For more details, please refer to the main paper.